Hello Finxters. Today we're looking at a question that is often asked online. That question is, how do I check if items in one list are contained in another list? In providing answers to this, we'll look at a number of options, all of which provide answers to a greater or less degree. We'll write a basic for loop for list comparisons. Then we'll move to a more classic list comprehension. We'll also explore lambda expressions and see if they might assist in this situation. And then we'll look at a couple of built-in Python functions, which we'll speak about shortly. And then finally, we're going to take a look at another data type, which may seem a bit strange, but that data type has some really useful methods that underpin it. And we'll use some of those methods to provide a really quick and elegant solution to this problem. And then we'll round this video out with some links to articles or books that will assist you to go further in your study. So, in looking at this question, I've actually done 4 possible answers that we may seek. One is, are any of the items in my list in a master list? And we'll get a Boolean response. We'll get a true or false, either yes they are, no they're not. Are all of the items in my list in a master list? And once again, a true or false response. Then, if we're seeking something a bit more specific, we're going to ask specifically which items in my list are in that master list, and we will return a specific list of those items. And then finally, we'll ask to see those items that are in the master list that are not in my list, and we'll return that as a specific list. So the code we're about to write will attempt to get answers to all of these 4 scenarios. So let's move across and do a little bit of coding. And as you'll see on the screen, I've created a master list called list A at the top there, and 3 smaller lists named lists B, C, and D. Now list B contains items that are all within the master list A. List C contains items of which only some are in the master list A. And then list D, of course, has no items in list A. And I've done this to ensure that we adequately test our code and also to highlight the type of return we can expect. So for the first code, I'll just be comparing list C with the master list A, and then in subsequent codes we'll check all the other lists as well. So let's start with building a basic for loop to iterate through list C and list A to check for a Boolean response as to whether any items in C are in A. Then we'll use a similar code to return the actual values that are in both lists. So let's get started. So we're going to ask for I in list C, for J in list A, if I compares to J, then we want to print true, and then we'll just get rid of that new line return at the end of the print function. Else, we'll just continue. And so that is going to go through the 2 lists, and it's going to tell us trues for all the items that are in list C that are also found in list A. Now let's also, while we're here doing some code, let's just go and do another line of code. Let's just put a line in there just so that the answers are a little more coherent. And for this second line of code, I'm going to create a blank list. And we're going to type essentially the same thing, except there'll be an append item in there. So for I in list C, for J in list A, if I compares to J, list result, which is the blank list that we've produced, append I, else, continue. And we'll spell that right, which would help. And then we will just go back here and we will print list result. So let's just have a quick look at that, and let's see if we can run that and see what response we're going to get from it. And there you see that we've got the answers that we were looking for. So we have true, true, true. So in list C, 3 of the items in list C are also in list A. And then the second for loop has actually returned those ones. So it's number 93, number 27, and number 83 from list C you will also find in list A. So we've answered the question, yet it took 6 lines of code for the true-false query and another 6 lines of code plus the creation of a new list to identify the actual numbers that were common to both lists. So it's quite verbose. Yeah. So why don't we try something else? And I'm inclined to look at a lambda function and see if we can return the duplicate values. So let's see how that looks. So we'll clear this for the second and we'll remove this code. And let's go to a lambda function. So we'll just go a simple print list filter lambda I in list A, list C, and we'll close out those. And let's run that and see what that gives us. And once again, you'll see down the bottom here that it's given us the 3 items 93, 27, and 83 from list C that are in list A. Now, I'm a fan of lambda functions, but if you've read my post on them, you'll know that sometimes lambda functions make code harder to read rather than easier. And I'm afraid in this case, I think that's true. So I'm going to ignore lambdas for this solution, and we'll move to a more classic list comprehension. So let's remove that code. And let's just do what I would class as a classic list comprehension. So we'll do a print. And here we'll want it returned as a list. So I for I in list A, if I is in list C. Nice, concise, readable code, very Pythonic. And if we run that, there you see again, we get the answers we're seeking, 27, 83, 93. So that's quite a tidy code, and it's a helpful response. And it's not a bad answer to our query. But let's see what else we might do. I'd like to explore 2 of Python's built-in functions called any and all. Any, as its name implies, checks if any of the items in a list are true and returns a corresponding true. So let's start with any, and we'll apply that to our lists. So let's go print any x in list A for x in, now we'll use all the lists for this one, in list B. And to save me typing, because I'm maybe one of the fastest single finger typists in the world, but I'm also lazy, so let's just redo those, and we'll call that C, and we'll call that D, and let's run that code. We'll clear this one. Let's run that code and see what we get. And there you go, true, true, and false. So remembering that any will check each list, list B, list C, and list D, and will return a true if any of the items in each of those lists is in list A. And of course we know that list B, obviously all of the items are there, so you get a true. In list C, some of the items, and then of course you'd expect a false on the last list because none of the items in that list are in list A. So that's helpful as far as it goes. But what if we want to know whether all of the items, because all we know is some are, we don't know if they all are. Well, of course, all we're going to do is we're going to change that any to all. So let's clear this. And once again, being lazy, let's go and just change that to the all syntax, which is exactly the same as any. And run that item again. And of course, now you see a slightly different answer because the only list, list B, has all of the items in list A. List C only has some of them, so you get a false, and list D has none of them, so you get a false. So you see the difference between any and all, and quite handy functions. But now I'd like to talk about what I believe is the most elegant and Pythonic method of answering those 4 questions we posed at the beginning of this video. And I want to introduce you to the set data type. And the set data type has some really useful methods underpinning it that will easily do what we wish it to do. And we simply convert our list to sets, carry out the methods we need, then convert the returned answer back to a list, all in one line of code. Short, elegant, and gives us precisely the data we wish. So the first 2 set methods we're going to use. The first is subset, and you'll see me type that in a minute. And that returns whether one set is contained in another set or not. And the second is intersection. And intersection will actually return the intersection of 2 sets. So those items that are in both will be returned. And let's get rid of this code here, and we will type up the is subset. So we're going to go print set, and this is where we have to obviously convert list B into a set before we can actually carry out the work. Dot is subset, and we're going to compare that to list A. So we're asking whether list B is a subset of list A. Let's just once again do our copying here. And we'll go list C and list D. And now we'll also do the intersection example so you can see it all on the same page. So let's just put in a new line there and put back the bracket which I've erased. And we'll do the intersection syntax as well. So print, and this time, because it's actually not returning a Boolean result, we will need to convert the answer back to a list if we want to actually use it as a list in our calculations or code. Dot intersection. And once again, we have to B, and once again we'll do our cut and paste. And we'll just change those so that you can see the response we get from each. Let's clear this and run that code. And there you have it. So once again, we can see that list B is truly a subset of list A, but the other two, of course, are false because only some of list C are in A, and then none of the items in list D are in A. And as you can see, the intersection is a really great method. It's told us precisely what is in list B that is in list A, which of course is all of them. It's list C, it just picks out those ones that are in list A, and then obviously returns an empty list for list D because there is nothing in D which is in A. Now I just think this is the most elegant method of solving the problem that we posed at the beginning of this video. Alright, so I think there's a bonus method or two here that I'd like to discuss because the set methods are wonderful for doing this sort of work. So there's three other methods I just want to show you quickly. One is called difference, and that returns a set containing the difference between the two sets. So effectively what it will do, it will return everything from A that is not in B. And so I think that could be really useful in some circumstances. There's a second one, is disjoint, and this is an interesting one. It will return true if two lists do not have an intersection, and it will return false if they do, which is the inverse of what we've been doing to date. And then finally there's is superset, which is obviously just a reverse of is subset. So is superset says, is list A a superset of list B or C or D? And you'll get or true or false depending on the answer to that. So why don't we code that up and see what that looks like. So what I'm going to do is, instead of doing all the writing again, I'm going to change this to is disjoint. And that will be A and B. And that was really messy. And we'll put our line return in there and change these to the various lists that we want to run that command on. And for the intersection one, I think we'll change that to difference. So let's see difference at use here. So you'll see very similar syntax across all of these set methods. And we're looking for B, C, and D, which is correct, A. And then the last one that we're looking for that I spoke of is superset. So we're going to go print set list A is superset set list B, and we will just copy those down. And I think these are quite a useful bonus method depending on what it is you're trying to do with the lists. Having an awareness of these is really handy. And let's just run these. Clear this first. Run these. And there you have it. So the is disjoint, of course, will return exactly the opposite of what we were doing previously. So that's going to say, because list B has all its items in A, there is an intersection, and therefore it will return a false. Because list C has some of its items in A, there is still an intersection, it will return false. The only time is disjoint will return true is when there is nothing in a list, such as in list D, that is in list A. So a bit of the inverse thinking there, but still quite useful in some circumstances. The way I've coded this is to find out what is in list A that is not in those other three lists, and there you can see the difference between the three. So you get all of list A for the last one, list D, some for list C, and even smaller amount for list B. And then the final one is superset. We know that list A is a superset of list B because everything in B is A, but it will be false and false for the other two. So let's just go back to the slides and review those methods. So the functions and modules we used in the video today, we talked about lambda arguments and we decided they didn't work here. But if you want to know more about lambdas, we do have quite a useful video and article in the Finxter blog on these. And lambdas are a small anonymous function that takes any number of arguments but has only one expression. And so you'd use it in a once-off situation, but in this case I think it's overkill and it doesn't make the code particularly readable. We spoke about the built-in function any, and that returns true if any item in an iterable are true, otherwise it returns false. And so we saw it return true for B and C lists and false for D, and all returns true only if all the items in an iterable are true, otherwise it returns false. And so it only returned true for list B and not for C and D. Is subset similarly returns true if all items in the set exist in the specified set, otherwise returns false. And then intersection, which I think is the jewel in the crown in this code, it returns a set that contains a similarity between two or more sets. And then difference obviously is the opposite of that, returns a set that contains the difference between two sets. And then finally the disjoint, which is that strange inverted one, which will only return true if none of the items in one list are present in the other. And then finally is superset, and that's really just to say true if all items in one set exist in the original set. So we've got some really useful things there, and I hope that this has helped you answer those questions that we originally asked at the beginning of this video. And just some more information here if you want to dive into some of the things we've discussed today. So to explore Python's built-in functions, there's a link there for a really comprehensive blog where you can click on each function and there will be a sub-blog for every single one of those. So it will give you a considerable amount of information for each built-in function. Any and all are in there, as are all the others, so really helpful. If you want to know a bit more about list comprehensions, there's a link to a list comprehension article and video. And If you'd really like to know more about writing some concise one-liner code, then there's a book that I suggest you look for on Amazon or wherever else you may buy your books. Python One-Liners, Write Concise, Eloquent Python Like a Professional. It's an outstanding book. I highly recommend it. So in summary, our task was to check if items in one list are in another, and we posed 4 questions, which we managed to answer as we went through our coding. We experimented with for loops and list comprehension code. We learned and trialed a couple of Python built-in functions, any and all, and then we learned and trialed the set data type and all those useful methods that underpin it. And to me, I am just sold on the set data type and those methods for solving this problem. I think that's a really neat, nice, concise, and Pythonic way to solve the problems, and I hope you agree. So thanks so much for listening, and I hope you enjoyed the video today, and I look forward to talking to you on the next video. Goodbye for now.